Hi there, let's talk about left to right addition. So left to right addition is a mental math strategy that enhances conceptual understanding. Now let's talk about what I mean about that. So first of all, we'll start with an example. So to add 26 plus 13, we're going to start from the left and add to the right. So we'll start by adding the tens. So here we have two tens and that makes 20. And here we have one 10 and that makes 10. So we add them together to make 30. And then we add the ones. So we have 6 ones there and 3 ones here, and that makes 9. And now we just join these two parts. So 30 plus 9 equals 39. Now let's contrast that with the traditional algorithm. Okay, so first of all, I guess I should just point out that when we do left to right addition, we have really good place value understanding because this 2, we see it as a 20. We see it as its value. This 1, we see it as a 10, not just as a 1, as a 10, because we see what the real value is. If we look at the traditional algorithm, where we line up the numbers like this, and then we add 6 plus 3 makes 9, and 2 plus 1 makes 3. Now notice that in the traditional algorithm, there's no need to understand what these really mean. We don't see these as a 20 and a 10 to make 30. We see them as a 2 and a 1 to make 3. So one of the advantages of left to right addition is true understanding of what the numbers actually mean. Let's take another look at an example that involves regrouping. So suppose we are adding 16 plus 15. In this case, we'll start out by adding the tens. So we have 10 there and 10 there to make 20. And then we'll add the ones. So 6 plus 5 equals 11. And then we simply add the 20 and the 11 to make 31. If we were doing this using the traditional algorithm, let's take a look at what that would look like. So if we line it up like this, we will begin by doing 6 plus 5, and that gives us 11. So when we do traditional addition like this, we're going to put a 1 and carry a 1. Now, why do we do that? Do we actually understand that we're regrouping here? Or is it just a memorized series of steps? And then when we get to this column, we add 1 plus 1 plus 1 to make 3. So I just want to make this really clear that when we do addition like this, using the standard algorithm or the traditional algorithm, there is not as much conceptual understanding. What we are doing here is we are following a series of steps that we need to memorize in order to find an answer. When we add from left to right, we actually have a conceptual understanding. We understand what's happening when we regroup. Okay? We understand the place value, the value of each digit, not just how it appears, just to be a 1, right? We understand it as a 10. So that's the advantage of left to right addition. Now, your students will still get to this point in upper grades, but we do need to start with conceptual strategies like left to right addition. And that will build their number sense understanding so that when they do get to the traditional algorithm, it all makes more sense and we don't have the gaps that we sometimes get. Now, if you've watched my other videos, you have heard me talk about the CRA model for teaching math strategies. This stands for concrete, representational, abstract, and this is such an important way to teach to make sure that we are building our students' understanding. So in the concrete phase, we are using hands-on materials that students can actually manipulate and move around, okay? And so base 10 blocks are a fantastic example of a concrete material that works well for left to right addition, and I'll talk more about that in a minute. The representational phase is when we are drawing representations of the tools that we might be using in the concrete stage. So for example, in the representational stage, maybe we draw pictures of base 10 blocks. to help us add. And then when we get to the abstract phase, that's when we're actually writing the numbers and the symbols and performing the math. Now, all too often, we rush to get to this abstract phase because we see this as the final goal, right? So maybe we spend 1 or 2 classes with some manipulatives, and then we rush to the abstract phase and start explaining it and just abstractly to our students. This is what I believe is the reason for so many of the gaps in understanding that we have when it comes to math and math fluency. What our goal should be is to give our students pictures in their minds of what they are doing. We want them to be able to visualize what is actually happening when they perform an operation. And we cannot give them the pictures in their minds if we don't give them enough opportunity to work with manipulatives. So even if you are working with upper grade students, I encourage you to use manipulatives because this is going to help them build and construct their own understanding. So let's talk about how we could do that with left to right addition. So base 10s, I think, are one of the best tools for left to right addition because it makes it so visual. So this shows 23 plus 14. And when we work with base 10s, we can write it out in the abstract form too to help our kids make connections. So here, it makes it very visual to see that we join the 10s to make 30, and then we join the 1s to make 7. And then that gets us to 37. Okay, and the same happens when we regroup. We can still use base 10s when we regroup. So let's suppose we have 27 plus 24. So here again, we're going to join the 10s, and then we join the 1s. Now let's take a look at what happens here. So now we've joined the 10s to make 40, and we've joined the 1s over here to make 11. Now, if your kids are familiar with base 10 blocks, they'll know that they can trade 10 of these 1s for a 10. So let's take out 10 of the 1s, and we're left with this. And now the 10s can be moved over to the 10s place, and we can very easily see that we have 51. Okay, so a lot of work with base 10 blocks is a wonderful way to help your students construct that understanding. Now, just very briefly before I finish, I just want to talk about the CRA model one more time, but in terms of a Venn diagram. So sometimes we see it as a linear path that we follow where we start with concrete and then we get to representational and then we get to abstract, right? And this might look like one lesson with base 10 blocks and then a few little activities with drawing, and then we just expect our kids to be working in the abstract phase with numbers and symbols. But I want to encourage you to think about the CRA model when it comes to left to right addition in a Venn diagram format. Because if you can incorporate some concrete experience, some representational activities, and some abstract into the same lesson, you are really helping to maximize the potential that your kids have to build their understanding of this strategy. So even during number talks, you might have be working on a board with abstract and representational, and then maybe you have an activity where you have your kids build a representation and then draw it and then represent it with an equation. So that's incorporating all 3 phases into the same lesson. And even if you feel that your kids are past the manipulative phase, you can still make base 10s available to them, and those who need them will use them if they need. I hope you enjoyed this video on left to right addition. If you have any other interest in learning about more math strategies, please check out my website at shellygrayteaching.com. Thank you so much. Have a great day.